All right. So, next item, gas density. When you're looking at gas density is going to be given to you in gram per liter. So you're either going to start with volume and end up with grams or moles, or you're going to end up with volume, so you're going to have to get to grams first. So just like with molar mass, it's gram per 1 mole. With gas density, it's gram per 1 liter. 1 liter of volume. So oxygen's density is 1.4 grams per liter, which means the conversion is going to look like this. 1.4 grams of oxygen is equivalent to 1 liter of oxygen, or 1 liter of oxygen is equivalent to 1.4 grams of oxygen. Okay, make sense? Okay, so that's how you're going to see a gas density. It's going to be given to you as density of oxygen, and it's going to be so many grams per 1 liter. So you're either going to be going to volume, going to liters using grams, or you're going to start with volume, convert to grams, then moles, then whatever else you need. So baby steps. Any questions before we begin? All right, off we go. As soon as I find my remote. Could be anywhere. So, oh, here we are. Boop. Oh, sorry, we'll do this one first. What is the mass of 5.9 liters of oxygen? So what should I start with in my T-chart? Yeah, I never start with the conversion, so 5.9 liters of oxygen. This is going to be a one-step T-chart, nothing down here. What's my next move?
Move it down.
Move what down? L. Yeah, move down liters of oxygen. And do I put any number here yet? I'm going to convert from liters of oxygen to grams of oxygen. We don't need to do moles because it's only asking for mass. So, boom, easy. And what number should I write up here for grams of oxygen? 1.4. So 1.4 grams. And for liters, I should write a 1. And do our math, and our answer is going to be grams of O2. So how much does a balloon with a volume of 5.9 liters of oxygen, how much oxygen is in that balloon? 8.2? 8.3? Okay. So 8.3? So far so good. Okay. So 8.3 grams of oxygen. Cool. Give me a thumbs up if you're comfortable with this so far. All right. Next step. What volume in liters of CO2 is equal to 3.1 moles of CO2? The density of carbon dioxide is 2 grams per liter. So how should I start this one?
3.1 moles of CO2.
Yep, start with 3.1 moles of CO2. What's my next move? Bring down mole CO2. And to what am I going to convert?
Grams.
Grams of CO2. Sounds good. So grams CO2. And I got a gram to mole conversion. Where does a gram to mole conversion come from?
2 grams per liter.
Periodic table. Right, periodic table. So, yes, psych. Just kidding. I was just checking to see if you were paying attention, Mr. Byers. Yes. 44? 12 plus 16 plus 16 is 44? If you say so, 44 grams of CO2 is 1 mole of CO2. Now, am I done?
No.
No, because I gave you a lot more distance right here. So yeah, what's my next move? Bring down gram CO2. Why do I bring down gram CO2? Because that's the unit I have. And now I'm converting to liters of CO2. The gas density the exercise gives me is 2 grams per liter, 2.0 grams per 1 liter. And now I'm going to have some number in liters of CO2. If it's asking for volume, wherever you start, you're going to end with liters. If it gives you liters, then you're going to start with it. 8.2? Oh, 68.2. 68? Okay. 68 liters of CO2. Question?
So you start with the moles, and then for the second part, are you, so you're asking for how many, because you have to convert to grams to get things.
Exactly. Yep. We'll revisit this more in the future, but this is where we are right now. Okay, give me a thumbs up if you understand this whole gram, mole, gram, and then gram liter thing. Okay, we're getting there? Okay, questions?
In the second one, the 44 grams, that's the molar mass.
Yes. I needed to use that to turn my moles of CO2 into grams of CO2. Other questions? Okay, the piece de resistance. Take a look at this exercise. Guys, focus. Adults talking. Oh yeah, that's a good one. If 11 grams of H2 and 98 grams of O2 react, what volume of H2 gas, in other words water vapor, will be produced? The density of water is 0.8 gram per liter. Now right away, what should jump out at you about this exercise? Exactly right. You're given 2 reactants, so there's our favorite reaction, 2 hydrogen plus 1 oxygen makes 2 water. You're given 2 reactants, H2 and O2. Anytime you're given 2 reactants, you need to do 2 T-charts. So go ahead and get this one started, and I'll be a little bit behind you. And question? 98 grams of O2 and then 0.8 gram per liter. So work this one out. I will be right behind you by a couple minutes.